Okay, today what I'm going to try to do is take this. See if we can show you how I can take this Dell ATX power supply that comes from an older computer. It when it had XP on it at the time. Then it stopped working, so I had the power supply taken out of it, kept it, and then I plan on using it for my electronics learning lab. But I was thinking, what if we could fit this whole power supply inside of the electronics learning lab? Is it possible? Well, if you have cable ties, it is. The reason why I say cable ties is because you can drill holes on it and you can strap it down with cable ties, and it'll hold it in tight and good. I'll show you how I got that done. Okay, here's electronics learning lab. As you see, there's a piece of paper taped on the top of there. I labeled it because the voltages are different. They're not the same. In fact, I thought about this because since you may not want to do this because then your voltages will be different, and if you try building something from that manual that come with it, you may have problems. Anyway, I don't think you will because probably with most of me, if I be able to do with this, we'll deal with these voltages. If not, you have to regulate it. Anyway, what I got here is got at the top of here, it taped up here, with paper up here that tells you the voltage and current it can handle up to. At the 3.3 volt rail, it can handle up to 10 amps. At the 5 volt rail, 15 amps. 12 volt, 12 amps. Negative 12 volts, half an amp. And anyway, I see it should be plus. That's why I took the battery. I had some left over. Some wires, 2 wires left over that I decided to use for a battery holder. That was on still, hook it up to that, so it wouldn't leave any extra wires left over. And it works. I'm going to show you inside it. Now I can take the whole thing apart. This light bulb you see here, it's a load. This power supply needs to have a load on it. Not all power supplies need a load, because I have one power supply before without it. But this one here must need a load on it in order to run correctly. It won't. What happens is it'll turn on and it'll shut off real fast without it. Hopefully, it don't burn out ever. Anyway, I'll show you inside it. As you see, there's the power supply board. There's a piece of paper I put on top of it. That paper there helps prevent it from it acts as an insulator. And that was prevented from touching anything on the top of the case, like a spring or the speaker or the LED board, from touching the power supply. Because you gotta remember, there's mains going through it, and we don't want that to happen. Because not only is it providing out the low voltages, it's running off the higher voltages as well. And it does work. What I did on this thing here, which I should have did, is I should have took the green and black and put it to there, and took the other black wire that went from here to the switch, here to the power supply. That's so then, because anyway, it's not going to be on if the green wire is not short of the ground, because the green wire power supply, because ATX power supplies, they turn on it only if the green wire is short of the ground. That's why you want to take the green wire and put it to ground between the switch. That'll allow you to turn it on and off all voltages. And here's a trick between the negative 12 and positive 12. The trick is that if you use those two rails, you'll get something higher than 12. You get like double of it. You get like 20 volts. 24 volts at the max. So if you need something that needs something higher than 12 volts, you can run off of those. But the thing is, it's going to be a half amp as a maximum. So you'll need to be careful of that. Anyway, if they go over it, what will happen is it'll shut off, and then you just unplug it, and then wait a while, plug it back in, and it'll be good as new, because there's a circuit breaker in it. Even though there's a fuse, I know there is a fuse on the board. I think the fuse is for like extreme cases where if ever the thing would draw so much current that it could be dangerously high, then it would blow that fuse, and then it won't work no more until you get a new fuse. Anyway, let's show you how it works. Unhook. How should I do this? I'll plug it in over here carefully, because I got my router and stuff hooked to that power strip. It's a brown cord. Yeah, I had to cut. What I did is I ended up cutting the wires off in there and using one of these power cords I left laying around. This one here is just a 2-prong cord. It'll do good as 2-prong. It won't. There's need varistors that were on the connect on it. They just did protect it from a surge. Probably should have brought it over. It probably wouldn't matter if it was 2-prong anyway. It won't protect it because it needs that ground. Anyway, get this off of here. Plug it in over here. As you can see, I have it turned on. LED lights up. You see the light there's on. And it works. In fact, I'm going to measure these voltages for you to show you that works. So on the bottom of it, inside it, there is no linear regulator or anything inside the Learning Lab. Only thing that did for to get more voltage on it and why they use 6 AA batteries was so that they're cheap and efficient way to be able to get different voltages from hang on, I'm gonna have to put the camera down for a minute. Okay, I have it hooked up to there. Right there you see on the meter is 3.3 volts and it's hooked up to the you see the 3.3 volt rail, which is correct. And if we move it to the next one, we should get 5 volts. So let's do that. Okay, it's still on. 5 volts or 4.95 at the most. Still good. Now if you want to move it to the next one, which is 12, positive 12 volts. $12.1.
Lunch is done, buddy.
Okay.
Alright.
12.1 volts. Now if we go to the next one, I have to change. Oh, and unhooked it. Oh, we'll just leave it there. We'll hook it up, leave it there. Let you know if that LED doesn't light up because it's in reverse polarity. Because negative 12 volts it will be in reverse. 12 volts in reverse. So let's go to the next one, which is negative 12 volts. These should light, and we should get negative 12 on. You get this wire to hold in place. Do it in a freaking hole. Negative 12 volts. These not lit up. We get negative 12 volts on our meter. And these two battery holders will give you whatever you have it wired to. I was hoping to wire it up to use 3 batteries, but instead I ended up having wired it up to just 2, which that's no big deal. I'm not going to go in back there and change it again, so I have to use more of my cable ties. So I guess I have to deal with using 3.3, using 3 volts from the batteries. Plus, also another thing is, is that the ground, if I have it wired, the ground will not be disconnected from the battery holder, to the breadboard, because it's not going to the ground. It's going between these 2 areas. And basically, that's how it works. So then by using those cable ties, the way it worked out pretty well. It made it so tight in there that the board doesn't flap around inside the learning lab, because it's so tight that it can run without. Yeah, so tight in there, holds it in there. And then if the paper on the top of it, it'll prevent any of these stuff that you see on anything that you see on this top part of the board. There's the relay, the buttons, the transformer contacts, the potentiometers, the LEDs. That from touching the power supply and shorting out. What will probably happen is if it was touching it wouldn't harm nothing until you use the thing. Then it could cause a short, and then it could shut out, and it can ruin stuff. But anyway, to be safe, I decided to put a piece of paper on top of it, and so it would insulate it and make it where it couldn't short out and stuff like that. What's with these screws up top of here? I had holding some screws in my hand. I didn't know I had screws there. Anyway, if I flick this switch right here, did you see it? The light shut off, and we're getting nothing on it. That's just low voltage. It's mixing. It's stray voltages on there. If I touch it, see how if I touch it like that, it goes 0. It's just stray voltage. Well, that's it for now. I hope you enjoyed this video, so thanks for watching. Hope you like it.